Hi everyone, my name is Julian Holland. I'm with the Skylaris Group at the University of Southampton, and my research is focused on the ab initio study of lithium intercalation into graphite nanoparticles. We use two novel methods in order to study this material. We seek to perform ab initio calculations on a nanoparticle, which we believe we are the first to do this, and we also decide where to place the lithium using the electrostatic potential minimum. In terms of the goals for the project, we seek to run quantum chemical calculations on this structure. We want to reproduce observations seen in experiment. We want to then validate our current method and see if this is producing what we would expect to see. And then finally analyze these structures and see if we can gain any new insights that would help with anode design down the line. In terms of how we do this, we take our 592 atom nanoparticle, we run it through we run it with a quantum chemical calculation. This ends up outputting an electrostatic potential. We find the minimum from this, place our lithium here, we end up with a new structure, and then we repeat the cycle, as you can see down here in the bottom left. In terms of our results, we saw a nice stage 2 structure being formed initially. However, there was a congregation of lithiums around the edges of the nanoparticle. This we believe in part due to the choice of termination, which is the hydrogen atoms, which are, and this basically ended up sort of this slight electronegativity difference ended up sort of polarizing these outer carbon atoms, which led to lithiums congregating around here. And then this effect was exacerbated the more lithiation that occurred. This charge transfer can also be observed in this density of states here, as we see the electrons being given up by the lithiums into the nanoparticle, which shifted the whole density of states to the left. Comparing to experiment, we can look at the open circuit voltage. We ended up producing a nice convex hull. And then we also were able to sort of, from this, form a voltage step profile. This voltage step profile was significantly higher than experiment, which is this orange line here. We believe this is in part due to sort of the perfect nature of this nanoparticle and also the fact that this is an unphysically small nanoparticle. We hope as we scale up, which is something we do plan to do, this effect will be somewhat reduced. We also didn't observe an AA to AB shift, and we didn't observe an AA to AB shift, and some of the lithium layers are slightly unbalanced in terms of the number of lithiums that went there. So in order to improve these problems moving forward, as I mentioned, we want to scale up. We want to maybe potentially look at some different terminations, something a bit more realistic of an SEI, and we want to look at different methods in order to speed up this process. Thank you for listening. If you have any questions, please feel free to contact me after this.